Okay, so we'll look at number 13 and 14 real quick. Question 13 and 14. We're going to be doing a little tabular integration, which I think we probably are pretty good at, but we've only done that once. So some of you might want to take a look. So what we said we wanted to do is put our U's on one side and our DV's on the other side. And I mentioned to you that I'd like the Oliate, the logs, exponentials, inverses, etc. to be there. Hold on a second, something's weird. Is this actually, yep, no, it's working okay. Weird, I just had a different screen, so I thought it wasn't recording for a minute, but I guess it is. Okay, there, now it's looking correctly. But we're going to put the 8x cubed here, and we're going to go ahead and proceed to take derivatives until we run out of derivatives to take. Now, clearly the next line down would be 0, so there's really no point in doing it. But now I need to take some antiderivatives, and the antiderivative of e to the 2x is 1/2 e to the 2x, and then 1/4 e to the 2x, and then 1/8 e to the 2x, and then 1/16 e to the 2x, and then 1/32 e to the 2x. Now that's a little obnoxious. I'll give you that. That's not so pretty. And then remember we said we are going to multiply down these diagonals until we run out of diagonals to do. And the first one is going to be positive. So I'm going to have 8x cubed multiplied by 1/4 e to the 2x. Plus I'm going to have 24x squared times 1/8 e to the 2x. But you want to remember that the first one is positive. The second one should be negative. The third one is going to be positive. So I got 48x e to the 2x, and there was I guess a 1/16 in front of there that I missed. And then last, it's a 48 times 1/32 e to the 2x. And that was a plus, a minus, a plus. So I guess this one needs to be a minus again, and then a plus c. Now, of course, we should clean that up a little bit. And you could do little things like saying 4 goes into 8 twice. And 8 goes into 24 3 times. And, you know, we could just keep doing that. That's not a big deal. I think you guys can all clean things up just fine. Now, for problem 14, this was a little bit of a tricky question. And this was just knowing that this is one of those little tricks that would happen. Regular U sub is not going to work for this problem. Even tabular is a problem. But anytime you see sine and cosine smashed together like that, something to remember is the sine of 2x is 2 sine cosine. So if you look at this thing, we could rewrite and we could pull that one of the 2's out of the 8 right here and leave a 4 and an x squared and be left with a sine of 2x dx. And now that fits ourselves into a nicer little story. Remember Liate, L-I-A-T-E. There's no logs, there's no inverses, but there is algebra. So we're going to go 4x squared, 8x, and 8. Antiderivative of a sine is a negative cosine, but I need to divide by 2. The antiderivative of a negative cosine is a negative sine, but now I'm going to take this guy, so it's going to be divided by 4. Antiderivative of that's going to be a cosine, but now it's going to be divided by 8. And last but not least, it's going to be a sine, and it's going to be divided by 16. And remember, the first and the last are going to be pluses, and this middle one is going to be a minus. And there's a lot of minuses at play in that story. So my first pull is 4x squared times negative sine of 2x over 4 minus 8x times the cosine of 2x over 8, and then plus 8 times the sine of 2x over 16 plus c. And yet again, we can clean up a little bit. I don't think I want to take the time to do a bunch of that stuff within this video because I don't want it to be longer because there's not a lot of math there. But you could clearly cancel the 4s here and you could cancel the 8s and the 8 and the 16 and clean it up just a little bit. So I think that should be good enough. Hopefully that was helpful. See you back in class. Bye-bye.